Hello children, how are you all? Hope you are doing well in your studies, right? We also aim or desire that you should do well in your studies. And these lessons that we are providing you, otherwise bringing out to you, we hope they will be helping you to do well in your examinations. Not only that, but also grow your knowledge about the science. Right, children? Now we'll get into the details. Now, children, if you go into the market or go to the market, so buy a few things necessary for our household or a house. Your mom, say you are going along with her, and she brings a lot of things, and she keeps them. Does she dump it in one place, or what does she do if she brings them home? So she'll be bringing soaps. The next one, some things as cereals or otherwise pulses, okay, right, and a few pens, books and all for you people. And say she buys new bed sheets and all. Okay, there are so many things that people go to the market to buy. So when they buy and bring them, we'll keep them. Will they all dump in one place? No, they won't do it. Is it not, children? So they would naturally be arranging those things in a proper order. So, okay, the cereals, pulses in the kitchen. The next one, bed sheets and all in the bedroom. And the books and the pencils and whatever, they are at your desk. That is your study table. And a few other things. Wherever necessary or where there are proper places, that is the place where they keep those things. So this is the arrangement. Arrangement and discipline is the order of the nature. So children, so you can see in the nature also you find that everything is arranged orderly. So how great the wisdom of God is. So we see the sun, we see the planets, we see the stars and all. So their movement in the orbits and all, how is that, children? That's speaking so much of order and discipline, right? So that discipline and order speaks that things in the nature, they have some order. So that order may also be there in the fine structure of matter called atom also. Is it not? Right. What is atom made up of? So we learned that atom is made up of particles called electrons. Good. Right? Atom has particles called electrons. This was discovered by Sir J.J. Thomson, Joseph John Thomson. Good. Right. Okay. Right now. After that, so what was his finding? Negatively charged particles. Electrons are negatively charged particles. These are the characteristics of cathode rays, the charge, the mass, etc. The next one. So there is a positive charge also which was found. Right. So we are not having an idea about the positive particles at the time. At the time of J.J. Thomson, there was no idea about the individual particle nature of positive charges. There's no idea. That's all positive charge. That's it. And there are negative charges. There is electrons. Good. That's it. Now next one. How are these arranged in the atom? That arrangement of the things that are found, the particles, different particles. You can see the electrons and the positive charge. How are they arranged inside the atom? So that study of arrangement of the subatomic particles in an atom, we call it as structure of atom. Right. Okay. So we talked about structure of atom. Right. In that series, now we talk about the first model of atom proposed by none other than Sir J.J. Thomson. Okay, when we go to Sir J.J. Thomson and ask him, Sir, what is your idea about atom? We'll see what he tells. And he says like this. So we talk about Thomson's model of atom. What is Thomson's model of atom? He says the only subatomic particles that he was knowing at that time were electrons. Right? And what did he say about this? He said the whole of the atom is like a sphere, ball, ball, sphere. Right, that's the shape. And that spherical atom is all positive charge. It's all positive. The whole positive charge is uniformly distributed. There's not much positive charge at one place, less positive charge at other place, and a very low or very high positive charge at different places. No, it's all uniformly arranged. So that is how the whole of the atom proposed by J. Thomson was like a sphere, and that is positively charged, uniformly distributed. Right, now, Mr. Thomson, where are the electrons? The Thomson said, yes, the electrons are also there in the atom. And how are they? The electrons are, which are negatively charged, they are arranged like, so these are electrons, and they are arranged like plums or fruit, nuts in a plum pudding. Okay, the whole of the pudding, the whole of the atom, it looked as a pudding, and in that the electrons which are negatively charged, they were placed like, not placed, they were embedded like, pressed into the sphere of the atom like the fruit and nuts in that plum. So this also is called as this structure of the atom that Thomson stated or proposed is also referred to as plum pudding model of atom. What is that? Plum pudding model of atom. Now in this we see what is this? It is the positive sphere of atom. And what are these? They are electrons which are negatively charged. Good. So this is the structure of atom proposed by Thomson. Good. Right now. So this is about the structure of atom, or the very first structure of atom proposed by any scientist. There was no scientist before him who proposed a structure for the atom. Now, right, so electrons are embedded like fruit and nut in a positive sphere of the atom, which was like the pudding. Right, so this also resembles some fruit that you eat usually in your summer times. Can you tell what it is? Yes, it is the watermelon. So it's looking like a watermelon, is it not, children? The whole red mass of the fruity mass, the watery fruity mass, that is the atom, that represents the atom, or that looks like atom. And the seeds, the black colored seeds that of a watermelon, how they are placed or embedded in it, they are so symbolized by these what, children? These electrons. So children, so this we can also address as a watermelon model of atom. So what model is that, children? So that is a plum pudding model of atom, or what is that? That is what is that? Watermelon a model of atom. So that's a model proposed by Sir J. Thomson. Right, okay, now. Right, children? Now next one. I want to ask you, is there any what? Right in it? He explained it. There's right thing. What is the right thing? Yes, atoms are neutral. Good. Atoms are neutral. They are positive charges. There are equal number of negative charges also. Good, happy. So positive and negative charges, they are equal. So that balanced out. And what happened, children? It is the atom is neutral. Okay, good. So children, that is how Thomson's model was stated. And let us get into the details of his proposal of how this atom was. The same thing, they write down the proposal of Thomson, and we'll understand a little further about the first structure of atom proposed, or the model of atom proposed by J.J. Thomson, right? So children, we are here, and so we can see the diagrammatic representation of the assumption of Sir J.J. Thomson. And what is the assumption, children? That the atom, the whole atom is positively charged. Okay, the whole thing is spherical, right? And then in that spherical atom, how are they? Negatively charged. So it is the whole atom is positive, whereas the electrons are negatively charged, and these negatively charged electrons are embedded, as if you place jewels in some gold ornament or jewelry. So they are embedded, placed like that into the atomic sphere. So this is the structure of the atom that was proposed by J.J. Thomson. Right now we look at here. So what is his proposal? First one, atom is considered. Atom is considered is an assumption and as a sphere of uniform positive charge. It's uniformly distributed. The positive charge is uniformly distributed. There's not more there and not less here. It's all uniformly distributed within the atom, right? Next one. And over electrons, the electrons are embedded in the atom, right? Okay, now how is the mass of the atom? So we have learned previously that mass of the atom is mostly because of the positive part, because the mass of electrons was considered to be negligible. We have learned that, right? Okay, so total mass of the atom is also uniformly distributed. This is the thought. This is also an assumption. And it said the whole mass of the atom, okay, it is uniformly distributed like the charge. Okay, right, that's it. The positive charge. I mean, the negative charge and the positive charge. Now, how are they? They're balancing out. Means the total number of negative charges and the total positive charge, they should be equal. Why? That's because of the neutrality of the atom. So why, children? The atom is neutral. So children, what is this model of atom speaking? First one, atom is spherical, and the total sphere of the atom is positively charged, and the electrons are embedded in that positive sphere of the atom, like fruit nuts or fruits and nuts or seeds, as in watermelon, or fruits and nuts in a plum pudding. So right, children, this is how the next total mass is also uniformly distributed throughout the atom, and the positive charge, that is the total positive charge in the atom, and the negative electrons, they are balancing out. So the positive charge is 10 units, and the negative charge would also be 10 units. That means if each electron is carrying 1 unit of charge, then there would be 10 electrons inside. So the charge, if there are 10 electrons inside, naturally the negative charge would be 10 units, minus 10 say, and minus 10. So it becomes 10 electrons will give minus 10 charge, okay, minus 10 units, and 10 units of positive charge will be plus 10. That will become minus 10 plus 10 would be 0. So the atom is neutral. So you explain atom is neutral, happy. It's all happy, right? Good. Now, the subsequent scientists, some of the findings of the scientists and researchers, it proved something is not right with this theory of atom. So what is not right? So there's something major is wrong in this, and that is the Thomson is explained the neutrality of atom, but one thing is not explained properly, that is how electrons which are negatively charged are shielded. Shielded means covered from the influence of the positive charge of the atom. How is this done? If they are not shielded, what would have happened? What would have happened? what would happen if electrons are not shielded from the positive charge? Instead, they are directly placed inside the atom. But what is happening? If that happens, the thing is, the whole atom will be blasting or bombarding or annihilating or destroying. But what is the thought to? Atom cannot be destroyed, matter cannot be destroyed, nor created. Matter is neutral, atoms are neutral. That's good. He explained neutrality, but he did not explain the idea of indestructible idea of matter. How? So negative charges and the positive charge cannot be together because two opposite charges, when they are together, there will be annihilation or bombardment. So children, so what do we understand from this? It's all right. Initiation is good, but the conclusion is a little diverted away from the actual truth. That is, matter is indestructible, but what Thomson's model is telling is that it is not helping or affirming the thought that matter is indestructible. So children, so this was what Sir J.J. Thomson's idea of matter was, and he was to a certain extent correct, but indestructibility or neutrality, indestructible idea of matter was not properly put forth. So okay children, and the subsequent scientists they followed this idea, but later on conducted so many more experiments, and the experimental facts were brought forth into the light, and through that, matter is made up of atoms, correct? That's also indestructible, but how is it so? Or how is it? That was explained by experimental proof. These are the assumptions of Thomson's Sir J. Thomson, right? Okay, but an excellent experiment conducted by the other scientists whom you know well, may not be, but still is a prominent scientist, Sir Rutherford, and his experiments gave a solid proof that atoms are not like water, Mr. Thomson said, but still we have to respect this master I should say, a teacher, a professor who helped 7 of his students to get Nobel Prize. And do you know, his own son was also a Nobel Prize winner? For your information, so J.J. Thomson also was a Nobel Prize winner. What an excellent teacher he is. What an exemplifying life he is. So children, so let us respect him because he was the initiator of all this cycle. So J.J. Thomson. Thank you very much.